In 1977, Ohio State University's Big Ear radio telescope stood as humanity's ear to the cosmos. Designed by John Krause, this massive parabolic antenna scanned the sky for narrowband signals, potential signs of extraterrestrial intelligence. Operating since 1963, it was part of the ambitious SETI project, analyzing frequencies like the hydrogen line, 1420 MHz, a logical choice for interstellar communication. The telescope's paper printouts, though primitive, recorded cosmic noise, until one night, everything changed. On August 15, 1977, volunteer Jerry Emin reviewed Big Ear's data printouts. Amidst the static, a 72-second burst of radiation stunned him, a sequence marked 6EQJ5, indicating a signal 30 times stronger than cosmic noise. Emin circled it in red ink, scribbling "Lao" beside it. The signal originated near the key Sagittarius star group, aligning with no known natural phenomenon. This anomaly would ignite decades of debate. The Big Ear team quickly convened. The signal's narrowband nature, a hallmark of artificial transmission, and its intensity defied explanation. Unlike pulsars or quasars, it lacked repetition or drift. Dr. Robert Dixon noted its resemblance to a projected interstellar beacon. Yet, without corroborating data, skepticism crept in. Was this a technical glitch, a military transmission, or humanity's first brush with alien contact? Researchers scrambled to rule out natural causes. The signal's 1420 MHz frequency matched hydrogen's emission line, a likely interstellar hailing frequency. It wasn't a pulsar, too steady, a comet, too strong, or earthly interference, no satellites aligned. The absence of Doppler shift suggested an origin beyond the solar system. By process of elimination, the WOW signal stood alone, a cosmic enigma. For decades, telescopes revisited Sagittarius. SETI's Project Phoenix and others found nothing. The signal's one-off nature deepened the mystery. Why would aliens transmit once? Some theorized it was a directed beacon now inactive or a passing spacecraft. Others argued it was a natural transient, like a yet unknown astrophysical event. Without repetition, the WOW signal remained tantalizingly unresolved. News of the WOW signal leaked in 1977, sparking global fascination. Headlines screamed, "Aliens contact Earth," while UFO enthusiasts linked it to Roswell. Carl Sagan, ever the skeptic, called for rigorous analysis. The signal became a pop culture fixture, inspiring films like Contact. Yet, the scientific community cautioned, extraordinary claims require extraordinary evidence, which remained elusive. Critics offered terrestrial theories, a reflected satellite signal, though no satellites matched the frequency, or a classified military test. Astronomer Antonio Paris controversially proposed comets 266P Christensen and 335P Gibbs, except they weren't in the area in 1977. The signal's purity and duration undermined these claims. Still, the absence of aliens in the equation appealed to Occam's razor advocates. The 1420 MHz frequency was no coincidence. Hydrogen, the universe's most abundant element, emits at this wavelength, ideal for interstellar messaging. Nobel laureate Charles Townes had suggested aliens might use it. The WOW signal's narrow bandwidth, under 10 kHz, further hinted at artificiality. If intentional, it was a cosmic hello engineered for universality. But without a reply, the hypothesis stayed unproven. Despite 50-plus years of searching, the WOW signal never repeated. SETI's Jill Tarter noted that sporadic signals are statistically expected if alien civilizations are rare. Alternatively, the signal might have been a one-time event, a dying alien transmitter, or a cosmic coincidence. The silence fueled the Fermi paradox. If life is common, where is everyone? The WOW signal epitomized this existential question. In 2017, Antonio Paris revived the debate, suggesting hydrogen clouds from comets 266P/Christensen could mimic the WOW signal. Critics countered, comets emit broadband noise, not narrowband spikes, and weren't in the beam in 1977. the theory gained media traction but little peer support. It underscored a key issue. Without the original telescope, dismantled in 1998, definitive tests were impossible. The wow signal embodies the Fermi paradox, the conflict between high probability of alien life and the lack of evidence. If the signal was artificial, why no follow-up? Theories range from civilizations being short-lived to deliberate isolation. Or perhaps, as physicist Enrico Fermi quipped, they are among us. But the wow signal remains our closest, if inconclusive, hint otherwise. Beyond science, the wow signal permeated culture. It inspired SETI at home, crowdsourcing cosmic analysis. Sci-fi authors wove it into narratives, from Arrival to the X-Files. Even today, it symbolizes humanity's yearning for connection. The signal's legacy isn't just about aliens, it's about our relentless quest to understand our place in the cosmos, armed with curiosity and rudimentary technology. In 1977, technology constrained the search. Big Ear had no digital recording, just printouts. Modern arrays like the Allen telescope can scan millions of frequencies simultaneously. Yet the wow signal's brevity remains a hurdle. Would today's tech catch it? Probably. Decode it? Unlikely. The signal's power lies in its mystery, reminding us that even our best tools are primitive against the cosmos' scale. Decades later, the wow signal endures as astronomy's greatest what-if. It pushed SETI to refine methods, like targeting exoplanets. While likely natural, its perfect storm of artificial-like traits keeps hope alive. Perhaps future telescopes, like the Square Kilometer Array, will find similar signals, or finally solve the riddle. Until then, Eamon's red pen marks humanity's closest brush with the cosmic unknown. The wow signal's allure isn't in answers but questions. Was it aliens? A fluke? We may never know. Yet it exemplifies science's beauty, the pursuit of truth despite uncertainty. As we scan the stars today, the signal reminds us the universe is vast, strange, and humbling. Whether a cosmic hello or static, it sparked a journey that continues, one frequency at a time.